Hi, welcome back to the A to Z of Python. Today is letter G. So we're going to be talking about generators. First off, what is a generator? Well, a generator is a function in pretty much every sense of the word, except for when it comes to the return part of the function, where you generally return your results to a variable or print them to the screen. It will not return the entire results at once. It will wait for you to ask for the results, and it will print them one at a time. So imagine if you had a function that says that takes the range of, like, say 1 to 100, and this would be better as a comment. There we go. And returns range times 2. Okay, so you have these numbers 1 to 100, and you multiply them by 2, and then you return those to the user. So that's a really basic function. And what you would be doing is you'd be sending a list which would contain basically 2 through 200, because it multiplies them by 2. And that person would take that list and do whatever they wanted to. Maybe loop through them and print them to the screen, or save them somewhere else, or whatever they want to do. So that's fine, very simple. You've all done it. You have a list of numbers, you do something to them, and then you return it. Well, that's fine until either the range of numbers gets really, really big, like tens of millions, or the complications get extremely complex. It can take a long time to compute, and the object, the list that you send back, can be increasingly large, and it can get so big that the computer just can't handle it. And so what a generator will do is say, take this, you want to take this range 1 to 100 and you want to multiply it by 2. Well, you can do it one item at a time, so one number at a time, and it will wait for you to ask it to do that, to perform that calculation and return it for you. And so you can sort of loop through the function one number at a time whenever you need the information. And it becomes a much more efficient way to do it. Now, it's kind of confusing. So if you're not following along yet, don't worry. I'll show you an example and it'll all make sense. So let's start with a function called line. And this is going to be in the form of y equals mx plus b. If you're not familiar with this, this is the, you have an x value and you have a slope. So the line goes up however many and goes over however many. And then you have a y-intercept. And this is a line, like a diagonal line. And you give it the x value and it will tell you what the y value is. And if you run enough of these, you can actually just plot them out and you can see the line. And this is used in math all the time. If you're not familiar with what this looks like, just Google this and look at a picture and it all makes sense. So what we're going to do is we're going to take in a list of x values and we're going to calculate the y values and return them to the user. So to do this, I'm going to ask for a start and a stop value for the x, the list of x, and we're going to do y equals 2 times x plus 1. So this is our line function here. So it's got a slope of 2 and a y-intercept of 1. So we're just going to feed it a bunch of x's, and it's going to run this little math equation, and it's going to save it to a y value. So what we want to do is actually make this a list. And we're going to do for x in range start stop. And we'll return y. So what this is going to do, again, it's going to take a start and stop range, say 1 to 10, right here. So from range, say 1 to 10. And for each one of those numbers, substitute x in here and save it to y, and then this will be a list because it's in these brackets. So it'll be like 10 values if we use a range of 10. So to get the starting stop, let's just create some sort of value, input, and we'll say input starting x value and b equals input ending value, and there you go. And then we'll do my line equals line AB. So there you go. So this is a fully capable function that can take a range of A to B, so starting, stopping x value, iterate over that, perform this function, and store the results in this list, which will be returned as y. So if I were to say print my line, and we run this, put in 1 to 10. Oh, there you go. So we need to make these integers. If you've seen a previous video, this will get you every time. These will be treated as strings. They need to be numbers. So we're just going to do integer. You could have an x value of like 2.5, but we're not going to deal with that right now. We're only going to use whole numbers for this. So let's try it again. There you go. So here's our list, and 3 is for x equals 1, it's 2 times 1 plus 1 is 3, so on and so forth. So hopefully this makes sense what we're doing here. It's a pretty basic function here, but this is something you might do. It's something that you really could come across. So let's take a look at the size of this list of numbers here, and we'll do that with import sys, and then we'll do print sys.getSize of my line. Then I'm going to divide it by this seemingly arbitrary number. This is the amount of bytes in a megabyte. So this returns the file size in bytes. So I'm going to convert to megabytes by doing this. So when we run this, it's going to print out the size of this variable in megabytes. So let's try it. So very, very small, not even 1 megabyte. So let's run it again and put in 10,000. Whoops, a range of 10,000. So getting bigger, still not bad, not big enough to be a problem. But let's say we put in 10 million. Oh. Try that again. 1 to 10 million. Alright, so the size is getting bigger. So you can see how this would eventually become a problem. And integers are actually very, very small to store in memory. And so even 10 million of them only takes up 38 megabytes. But what if we were to convert the list into a list of strings and run this for the same amount of numbers? Okay, so tripled the file size. So you can see that the contents matter, obviously. So imagine that instead of returning integers or strings, you're returning dictionaries or list of lists or really big numbers or like database entries, like just whatever it is that's bigger. This could rapidly grow to exceed the available memory that you have, and your script will just not run. So it becomes evident in production and in a bigger scale. It cannot work this way. So we have to think of a better way to do it. So let's start by using a generator to sort of replace this. So we'll get rid of this stuff here. We'll get rid of this one. And let's change the way this looks. Let's say for x in range start stop, I'm going to do y equals 2 times x plus 1. And then instead of returning y, we'll yield y. Alright, so what will happen here? Let's run this, Shouldn't explode on us. Okay, so it's running through just fine. So what happens when this is now a generator, but simply because we put the yield instead of a return. So what happens is when you call the function like we did here, it runs all the way till it finds a yield, and then it sort of pauses and it waits for you to ask for this value before it will go through it again. So how do you do that? Well, it looks like this. We're going to print out and use the command next, and then the object, and that's going to say next means do this. So give me this y value. And then it goes through it again and it stops again. And when we call next again, it'll print the next one and so on and so forth. So we could just do print next my line again. And let's actually just copy this. And we'll do it 4 times. So what we would expect here is, even though the range may be like 1 to 1,000, we're only going to get the first 4 results. So it's going to, this next command will tell it to yield the y value 4 times. So let's try that. So put in some big number. But you can see we only get the first 4. So even though we've created a function that we've told it to run through the entire range, it's not going through the entire range. It's only going through the first 4 because we've only told it to give us the next value 4 times. And so we're harnessing the power to sort of start and stop the execution of our function whenever we want to. And this is where the power sort of starts to become a little more obvious. So this is just so you can see that there is a yield in there, but there's a way to simplify this function. So we can rewrite this function as this. So we can say y equals, and if we put like the parentheses here, this will become a generator function. And so whatever we put in here will essentially be assumed to have the yield in there. It just kind of fills it in for you, so you don't need it. So let's try that. We'll do y equals 2 times x plus 1 for x in range A to B. So we won't need this anymore. And we can get rid of these. So this here is the same as this, if that makes any sense. It's kind of crazy, but if you think of it as being, this is the function, the math equation, and we're going to run that substituting x in for the range A to B, which we'll specify here. You can see that it's going to do the same exact thing, but instead of running it all at once, these extra parentheses here sort of tell it's a generator, so it will yield by default, and it will only execute this when we use the next function. And so therefore this y will be equal to the starting point, and it will iterate once each time we call next. So y will just basically change every time we call next, and it will be the result of whatever the next number in line is. So let's get rid of this, and you can see how clean this looks first of all. So it's like super sexy looking, really, and it gives us the ability to do everything the other 2 approaches could do and more. So at this point we can just print next y. I don't know why I keep typing that. So let's try this. We'll just, whoops, we'll do it twice. Run that. And there you go. So pretty cool. And it's not really limited to just doing these print statements one at a time. This is iterable just like anything else, and we could do a for loop on it, and when we print it and the for loop is inside that, Python is smart enough to call next on behalf of you, which is really pretty crazy. And I'll kind of show you how that works here in a little bit. But let's say like a practical, well, let's just do that actually. Let's do for n and y print n. Let's see what happens. There you go. So you notice there's no next here and there's no yield here. So the two things that make it clear right off the bat that it's a generator are absent. But the thing to know, like I said before, is that this will indicate that it's a generator. And Python is smart enough that when you're iterating through a generator, it will call the yield function for you automatically for each loop, for each iteration of this loop. So you can do a whole lot with very little code if you understand how generators work. So this is like really, really cool. So when would this be practical? Okay, so a lot of people ask, well, why would I use a generator? Well, a good question. Let's say you had, you're using some sort of API and you were sending it chunks of data. So you wanted to send it Y values. And let's say that the API can only receive 100 Y values at a time, and it's limited to, you can only call the API once every 5 seconds. So you couldn't, if you had, say, 1,000 Y values, you ran this for a range of 1 to 1,000, for example, you couldn't send them all at once. You would be overloading the API. So you'd have to break it up into chunks of 100, and then you would have to wait 5 seconds in between each call to the API. So how would you do that? Well, we could do for I in range 100. We could print next Y. And let's see here, time.sleep, 5 seconds. And we'll import time so that we can have a break here. And well, let me mute my Hangouts. There we go. Okay, so what we're trying to do here is iterate through this for the entire range, but what we need to do is only do 100 at a time. And what I want you to do is sort of imagine this as you're building a JSON in here and calling the API like as a post. Okay, so we're going to print them to the screen so you can see what's happening, but you might be doing all kinds of different things here, but the point is that we'll only get 100 values at a time, which is pretty sweet. So let's run this for 1,000, and you'll see that it gives us the first 100, and in 5 seconds we'll get another one, and in 5 seconds we'll get another set of 100, and it'll keep going until it's done. Now you're going to notice something bad happens here when it gets to the end. And this will be important to understand. We're going to get an exception. So hopefully this won't take too long. And I'll go ahead and talk about the exception. So when you're calling next on a generator, it doesn't know where the end is. So if we, okay, actually we didn't. Yeah, we did. Okay, there's the traceback error. So there's something called stop iteration. So what happens is you can keep calling next on a generator, and say you have a generator that returns 10 results and you call next 10 times. Well, when you call it the 11th time, you've sort of exceeded the range of the generator, so there's nothing to return. So when you get to the end of the list, you get a stop iteration exception, and you need to handle that. So if you've seen the exception handling video, it should be familiar. We can just do try, and then we can do except stop, oh, not that, stop iteration, and then we can break out. So what this will do is it will tell us, you know, if we run all the way through, just keep going until it kicks out this stop iteration exception and then break out. So Let's reduce this time to 2 seconds so it can run a little bit faster, and we'll do it just for a smaller range here. So in about 10 seconds we would expect to see the exception, but since we've handled it with this try except, there you go. So nice and clean. So it works. So again, you can imagine in here if we were to take these 100 at a time, put them in a list or something like that, convert that over to JSON and post that to an API, we could both be within the limits of the API and the rate limiting as well. So that's pretty powerful. So what else can we do? Well, let's see. There is a thing called Itertools, which is pretty cool. So we'll import that. And Itertools is something that you'll use extensively if you start using generators. So like better to learn about it now than later on. So we can actually use Itertools to get chunks of data from our function. So let's go back to the line function. Actually, let's get rid of this. And let's try it this way. I don't know if this will work, but we'll actually I'm going to show it as a function just so it kind of makes more sense what we're doing here. So I'm going to copy some information back over. We're going to go back. Alright, so we're going to do for in Itertools dot islice line 20 print in, and this needs to have start stop or A and B. There we go. Sorry, kind of trying to do this on the fly here. And let's see what happens. So if we look at this, we should expect for in Itertools.islice, so it's going to call this function and it's going to tell us to get the first 20 results, hopefully. So we'll put in a range of 100, and there you go. So we actually are only getting back the first 20. So, well, when does this become useful? Well, let's say we redefine line as something without a starting stopping point, and we say x equals 1, and we do while true, so we create an infinite loop here, and we say y equals 2 times x plus 1, and we yield y, and then we increment x. So what do we have here? We have another line function, and we're starting at x equals 1, and while true we're going to run this and yield it and then increment. So this will actually loop forever. So we'll start with 1 and it'll go on forever. So we could have infinitely many values, one at a time. So 1 to 1,000,000, 1 to 1,000,000,000, whatever you want. And we'll get rid of these. So now we've allowed the user to specify the range without asking for like a start stop point here. So let's get rid of this. I'll run it again. And there you go. So it's going to spit out the first 20, starting at 1 and incrementing by 1. So that's this is a infinitely scalable function, and we can basically tell it how far to go. But we can take it one step further, and we can say, for example, y values equals, and we'll create a list of Itertools.islice, and we can specify a range. So like say 49 to 100. And then we'll print y values. So what do we think is going to happen here? Well, what's going to happen is it's going to create a list of numbers from 49 to 100 that are the result of this function. which is pretty wild. So there you go. So that's the basically the 50th and on value of this function. So even though it starts at 1, this tells it to just skip past all that and start at basically 50 and go all the way up. And that's pretty nuts, because that allows us to have one function that can either return a range from like the starting point to a certain point, or it can return values for a range anywhere in the middle. And this function is like, it's infinite, you know, it could loop on forever, but we can tell it just for ranges that we want. And this is extremely powerful. If you had like there's one example is the Fibonacci numbers, and there's like an infinitely large amount of those, and you maybe want Fibonacci numbers ranged between 200 and 300. You could use this type of approach to get that. And that's just sort of the entry level for generators, but hopefully using this you can see a couple of different ways that it would be valuable, and hopefully that wasn't too fast. So watch it again. If you have any questions, leave comments, and thanks for